Okay, this is Pokey again. I'm going to do a little more talk about my Haas programming workbook. I was given two of these, mill and lathe, in class. Good thing I found it, but I was on my Google Classroom and my teacher gave me these to download, and the pages and the whole PDF file. So this is my exercise out of this book, which is page 66, right here. And I was told to read from page 60 on, discussion of cutter compensation. And I noticed there were some examples and why you would want to use it and stuff. And I got some, oh, is that my phone? Okay. Looks like there's a lot of math involved here and why you would not want to do it that way. It's very hard to figure out where the tool center is. So these are a part program using cutter compensations. This is a good sample right here. And another good sample. So we can look at that using an undersized tool, which means it doesn't matter what size tool, I guess. You can just compensate. And another one here talking about using it as a roughing and finish cut. So if you gave it a separate D number using the same profile, you can make one tool be a little bit bigger than the other. So this would be finish tool, that'd be roughing pass. Or you can even separate the tools, I would imagine, like if you're cutting steel. So here's I found my book, but I was able to download this on my Google Classroom. So I did what my teacher told me to do, is write down all my X and Y coordinates here. Oh, I think I need some light. There we go. Okay, so I wrote down all my X and Y coordinates here. And I have the example over here. And I can start plugging in the coordinates. And he told me to scan it, so I took a screenshot and submitted it for grade. And then he said to go on to compensation number 2, which I had already downloaded. The advantages of cutter, more reading, okay. So I did the same thing here. I got my 0. I figured out all my X's and Y's. Okay, and then it said here what size tool. And in this one, you need to calculate feed and speed. Now, I know in my book, good thing I have my book now. I'm sure I can Google it. It's right here. Revolutions per minute equals surface feet times 3.82 divided by D diameter. And inches per minute, feed per minute is feed per tooth times teeth times RPM. So I got all that. I got a 4-flute. But I actually found this calculator right in the control under help. So here I am, I'm plugging them in, and it says 275 feet per minute. And that's 1401 RPM. Oh. And it says 4 flutes. And feed is what I want. It says chip per load or per tooth, 0.0025. Oh, 14.05 inches a minute. So there's my, and I wrote the program by hand because now I had, where's my other page now? Oh, here it is. I had a good sample. So I started plugging in the numbers. Only I'm using tool 12. I got my RPM figured out. I had 1400, yeah. 14 inches a minute, yeah. I'm using H12 and I'm using D12 to match. And I plugged all these in and I hand wrote them in here. And I got my program right here now. I typed this in by hand right here. Pokey T12, just like this. Okay, and then I go to my graphics page and hit cycle start. There it is. I even went into the tool register. Where's this tool? Right there. I had to put these numbers in because it says radius, so I had to be careful. I was told that sometimes these say diameter, sometimes they say radius, so I got radius in there. And we had to put some false numbers in to get it to work because it was actually hitting an over travel condition. We had to adjust the y-axis. And then originally I had missed some of the R's, so it gave me some alarms. Let me look at the alarm messages. I was told to, right there, see? These are all the alarms I had. Cut a comp interference, Y over travel, invalid R. So these are all ones I missed in the beginning. It's even got a history here, today's date. So I was able to do that. And then I took the program and I downloaded it on the USB and brought it into my computer here and ran it on something called, let's go to my class. My class is here. And I'm in the B class. Class work. Here it is, Cutter Comp, and use NC Viewer, this one right here. So I had my USB, oops, I don't want to save that one. I'm going to open, there's my file, 40 right there. Open, and there it is right there. It's all right there. So I didn't really need the simulator. Let me get the view here. Yeah, right there. You got a little bit. Home, top. How do I move this over? Oh, it's rotated. Home, top. Can I rotate this? I'll go to home view. Alright. Alright, so here's my program. It says Pokey WB. I loaded it in. Yeah, I just loaded it in. I can have my digital readout on or not. Vertical Z up. And you actually can do lathe. Look at that, it does lathe. And I'll hover over this. That's play. That did everything. Let me rewind this. Alright. What's this one? This is like single block. Single block, 1, 2, 3. There it goes. Down, over, curve. G3, G1, G2, G1, G1, G3, G1, and cut a compensation off and up and go home. That was it. So I got a real good handle on this, how this works. So when I actually had some issues, I was able to fix as I went along. So this is a pretty good tool here. So right here was my class. I had Haas workbook, some videos. Right here is the workbook online, everything right here. The page, these are the pages. I downloaded those. So now I need to submit this, the last part of the puzzle. Until I ran it in the viewer. Okay, thanks.